Hello everybody and welcome back. Today we are looking at the question number 242, which is called valid anagram. This question is classified as an easy question, however, it's a really good problem if you want to show that you know what you do in terms of time complexity. Alright, cool. Let's move directly to the board now. Sweet. So the question states, given two strings S and T, return true if T is an anagram of S. So what's an anagram, guys? Anagram is a string that is formed by the letters of another string or phrase. However, if we see the constraints of our problem, it states that S and T consist of lowercase English character only. That's really good and really helpful because we don't need to consider any white spaces or special characters or uppercase characters. Sweet. So I've got for you here two test cases. For the first test case, we've got the word rat for the string S and the word car for the string T. We can see directly that T is not an anagram of S because the letter C is not part of the string S. And if we want to do that algorithmically, the brute force solution would be to set up a pointer here and iterate through all that string and find the match. If we don't find the match, we return false or we break out of the loop, something like that. And of course that won't be a problem when our strings are only 3 characters long. But as the strings grow, the time complexity is n squared and our algorithm will become really slow. So I'm going to show you guys when we move to our code a solution which is just linear. And of course we are going to use a hash table for that. Alright, and for the second code solution we can see that we've got the word cat and the word act, and we can see that the string T is an anagram of S because all the characters of string T are included in S. Sweet. Let's move to the algorithm part now. And as I said earlier, what we are going to do is we are going to use a hash map. And I was thinking to just use a classic loop. However, I'm going to use the reduce method from JavaScript. I know some of you hate it, some of you love it. I am in the latter one. So let's move on. I'm going to create the hash map variable and I'm going to take the string S and convert it to an array, and after that apply the reduce method. The reduce method receives one argument, which is just a callback function, and for this exercise I'm going to use a flat arrow anonymous function. And that function is going to receive 3 arguments, but however we only need the first 2 for this exercise, which is the hash map and the iterator. I'm going to call it letter. Alright, so now what we are going to do is to populate this hash map with values. So we are going to say that if the letter is in the hash map, then do something. Otherwise, what we need to do is actually to create that property in our hash map. And what I'm going to do is that bit. Sweet. So now that we have created that property, we need to go back to the first case where the letter will be in the hash map. And what I'm going to do is just increase the number of occurrences of that property. So what I'm going to say is hash map of a letter plus equal 1. Sweet. And at the end of the reduce method, we just need to return our hash map. And here we need to initialize our hash map with an empty object because we use the reduce. Sweet. So now in the hash map we've got value pairs, key value pairs, which are actually the number of occurrences of each letter in the string S. So what we need to do now, we are going to iterate through the second given string and reduce the number of occurrences from our hash map when we find a match of that letter in the string S. Here I was taking again to use JavaScript, a higher order function from JavaScript. However, if we use a higher order function, we cannot break out of the loop. So if we have really long strings, that won't be time efficient. So I'm just going to use a classic for loop. And the break condition is going to be t length -1, I plus. Sweet. And now we are going to say if the t of I, so if the property that we find in, if the letter in the t of I is a key of our hash map, then reduce the number of occurrences of that letter from the hash map. So minus equal 1. Otherwise, here is when we need to break. However, in order to make that easier, I'm just going to return false, because that's exactly what we are asked to do. The output will be a binary output, either true or false. Alright, so now we have excluded all the letters, and what we need to do is to iterate through the hash map and have a look if there are any letters that we haven't decreased the occurrences. For example, what I mean that sometimes the word S might be longer than the word T. For example, if we have S, A, B, C, D, and T, A, B, C, by doing all that process, we are going to have an empty hash map. Sorry, we are not going to have an empty hash map. We are going to have a hash map with just one property, which is going to be D is equal to 1. The other properties will be equal to 0. So in order to find that edge case, we need to say for key in hash map. If the hash map of the key, so the value, is different than 0, then return false. And this is the case where we have actually found, from the above example, if you remember ABCD, ABC, the property D, the key D. So we have handled that occasion as well, and now we are in the phase that we need to return true. So if we just return true, because we have excluded everything else, then we are going to return true when we actually have a match. Let's run this code. Super, and submit it. Sweet. Yeah, that's all for today, guys. If you liked this video, give it a thumbs up, share it with your friends, and if you haven't subscribed to my channel, please do it. Catch you in the next one. Cheers!